laws of logarithm. So we're going to talk about laws which allows us to move things around. And then we're going to use these laws to solve problems. So I'll shut up. Okay, so we're going to use these laws to solve problems. And where these laws come from, so log of a times b equals log of a plus log of b, comes from the fact that here if I have 9 times 3, or a times 3 times a times 4, this is equal to a times a to the 7th. And notice here that if I make this my a, I guess I should not have done that. If I make this my b and this my c. Here. Let me not do this. Let me do c. Let's do tiny c to the third times tiny lowercase c to the fourth equals lowercase c to the 7th. That way I'm not mixing up my notation. So if I call this a and call this b, here if I have log of, I guess I have log of c, let's do, oh yeah, we can have log of tiny a. Log of tiny a of c to the third and c to the fourth. That's equal to log of a times c to the 7th. But also notice here, if I have log of a of, oh, I know why I was choosing a. C to the third plus log of a c to the fourth. These all end up being the same. And actually it's easier to see as if I had it as I really did a the first time. So let's go back to a for 1 second because that actually makes the calculation easier. Because a to the third is 3, a to the fourth is 4, 3 plus 4 is 7. And here if I have a to the 7th, it's also 7. And so that kind of shows where it comes from. So all these log rules come from how exponentials behave. Okay, oh, someone's in the way now. Remind me, those two who came in late, when we switch notes to tag you into the attendance. Okay. So here, all these come from log rules. So here, if I divide two numbers, it's like minusing the exponents. If I multiply an exponent times an exponent, it's like multiplying something by the exponent. Let me just kind of quickly show that. So if I have log of a of 4 times 3, this is the same thing as log of a to the 12th, which is of course 12, which is also the same as 3 times the log a of 4. So that give me 4, 3 times 4 give me 12. So that's basically why these log rules exist the way they do and why they operate the way they do. Are these proofs? By no means, but it's just kind of a way of seeing why these things work. So let's actually crunch through some of them. Let me open up something really quick for me. There we go. All right, so could we actually compute this before we did it? And the answer is yeah. Log of 2, or log base 2 of 4 is 2, log base 2 of 8 is 3, so this equals 5. Or we could put it together using our log rules, so log base 2 of 4 times 8, which is the same thing as log base 2 of 32, and 32, right, log base 2 of 2 to the 5th, which is just equal to 5. Okay. Now we can use this method to solve things we couldn't solve in our heads straight away, but we can use it to combine stuff together. So here if I have log of 2 of 80 over 5, well, that's the same thing of saying log of 16. my math's correct today. And log base 2 of 16 is 4. Now here, I can do this two ways, and let me show you doing it two ways. This one I can just crunch correctly, right? Negative 1/3 times the log of 2 to the third is negative 1/3 times 3, which is equal to -1. Or I can put this in log base 2 of 8 to the -1/3 power. 8 to the -1/3 power is the same thing as saying log base 2 of 1 over the cubic root of 8. That looks like an 8. The cubic root of 8, of course, is 2, so, oh. So this becomes a half. Log base 2 of a half is -1. All right, so these are just rules to help us to move logs, to mess with logs. And sometimes we're going to want to put things together like we've done here. And sometimes we're going to pull things apart like we've done here. So let's do that. So here, if I have log of 5 of this, this is multiplied by 3 things. So I can write this log of 5 of 6 plus log of 5 of x plus log of 5 of y. So here, instead of putting it together, I can pull it apart. Let's do this one. So here, if I have logs, I can pull out, so I'll have ln of x cubed plus ln of y squared. Then I can pull this out front, so ln of x plus 2 ln of y. Okay. So I'm just using these rules to put stuff together and pull them apart. Here, if I have something a little bit more complicated like this, the common rule of thumb is everything up top is positive, everything down below is negative. If you want to make your life easier, right, this is x cubed times y to the -1/2 power times z to the -2. And what I'm doing here, clean this up a little bit so I'm on the wrong layer. There we go. Is here I'm just writing this all. Here I'm just writing this all on one line. And then once I've done this, I can just write, I'll put my little line here. I can write ln of x cubed plus ln of y to the -1/2 plus ln of z to the -2. And then here I'll have 3 ln of x minus 1/2. Oops, I forgot my ln. Minus 1/2 ln of y minus 2 ln of z. So you can write it all in, you can put it all in the numerator just by making the stuff on the denominator negative, right? So whatever power here is a negative, or you can just do it go straight for it. Here I can go x to the third. This is on the bottom, so this will be 1/2, right? Because here's my power is 1/2, it's on the bottom, so it's negative. Ln y, or -2 since it's on the bottom, ln z, using this rule. So you'll do a lot of homework problems this way. I give you a lot of things just to practice on this. All right, or you could go the other way. And so this is all this section is just putting these things together, pulling them apart. That's it. So here, I'm going to put this one together. So here I'm going to have ln of x to the 4th plus ln of x plus 1 squared. And then if I put it more together, I'll have ln of x to the 4th, x plus 1 squared. And so that's all multiplied together. And we're going to use this right here to solve problems. Oops. So it needs to be let in again. There we go. Where did the 2? Oh, the 2 went here. Okay. So the first step here is I moved the exponent in. Very good question, very good question. And then I multiplied it together. Here, if I have all this, I can put it all together. So notice here, there's two things we can do. We can just blindly just do what we're supposed to be doing here. So here I'll get log base 7 of x plus 1 squared. And here, yes, and then we'll have plus log base 7 of x minus x plus 1 to -1 plus log base 7 of x third to the third. And we can multiply it all together, so we get log base 7 of x plus 1 squared, x plus 1 to the -1 power times x plus 3 plus 2 to the third. And then to simplify this, I can just make this, I didn't leave myself room for it, log of 7, I didn't leave room for it. I'll do it here and then erase it. Log base 7 of x plus 1 times x plus 3 cubed. And because here, if I add up these, I can get this to be just a 1. Or if I was paying attention, which you may not be, right? But if I was paying attention, this is 2 times log of x plus 1 minus log base 7 of x plus 1. So I can just do that. I could literally just do the arithmetic here and save myself time. On the quiz, do we have to simplify like you did? Let me answer the 2 questions. If it says simplify, would you distribute the exponent? So if it says expand or combine, it'll tell you which way to go. Okay, so I'll make sure to do that. For the purpose of the homework and this, we do not need to FOIL. We will need to FOIL next time. So we will be doing FOIL. On the quiz, do you have a simplify like you did on LN? Like here? You know, I don't remember what's on that. I wrote it a few days ago. I need to do the last edits tonight, so I will do that. Let me take this. As long as I have this up, I'll check in the 2 people came in late. The 2 people who came in late were Alex and Jay. Yep, and yep. Okay, so I got the 2 people that came in. Let me look at the quiz real quick. Quiz. So do we just simplify as much as possible without solving? Yes, that's all we're doing in this section is simplifying as much as possible without solving. Next section we'll solve. So before the day is out, we'll get there. Quizzes. I was like, all of a sudden there was no quizzes. I'm like, oh my gosh, I lost everything. What do I have in the quiz so far? I have a simplify rational. I have simplify some exponential thing. I have interest. I have an interest problem, which you guys should have crunched on. So takes that alone with compounding continuously, write a domain of a log function, write out what e is, solve for log of e for 3 times, evaluate something. No, I have you evaluate 2 logs where you can do simplification rules, right? But I think the two questions I gave you are just two expressions and you solve for x. Okay, so that's what's on the quiz. Because you can't do this material. Well, if you can't do this, you can do the next section. All right, so just for funsies, let's have you guys try this real quick. Tell me what you get. So actually give this one a try. I'll wait until two people give me an answer. See if you understand what's going on. B would be combined. So I'll have you guys combine the following B. I want you to actually try it. So that's the first step. Now you can do one more step. So you're on the correct path, Emily. So after we put them together, remember we can still make it all a single using these rules, right? So here you've done this rule. Now you can do this rule. All right, so what do we got here? Yeah. So, yeah. So So both those answers are correct. So let me just run through it for everyone. So here, the first thing you want to do is pull in all your exponents. So you have ln of y to the fourth plus ln of x to the minus third plus ln of z. Multiply it all together, you get ln of y to the fourth x to the minus third plus c. Ln of y to the fourth z over x cubed. Okay, so that's the way to do that. I always suggest pulling in the exponents. That way you're only doing multiplication, because I find at times when students try to say, well, this is divided by this, but multiplied by this, sometimes things don't get filtered in the right spot, right? What's up, what's down, okay? Typing sucks, you have to hold this. Yeah. All right, and so the last one here, so here I have 2 log of 5 plus log base 7, 2 log base 5 of x plus log base 7 of x plus 1 minus 3 log base 9 of x plus 3. The only thing I can do here to make this simpler is bring in the exponents. That says hog, not log. I don't know how I managed that. Actually, I do know how I managed that. I was going to type in ln, realized I wanted to type in log, and it just all somehow came out to be that mess. Oops. 9. So this is about as far as you can take it. Since these logs don't match, you can't do anything. So we're done here. Okay. So we are done here. All right, so let's get to the next thing. So this is how you type in, so change the base formula. This is used to type stuff into the calculator. That's all it's used for. So most standard calculators will have a button for log and a button for ln, right? Most calculators have these two. Now, if we're using our magical Wolfram Alpha calculator, I think you can actually type in log base something. I think you can actually do that in the calculator. But most of them, use one of these two. You can actually use ln of x over ln of b, and that's what I almost always use, because for my calculator I actually have in my bag the TI-89, which is still 150 bucks. It was 150 bucks when I went to high school, and that was not yesterday. That shocks me. I was like, I know they can produce that calculator for like maybe $20. So this is just how you type it in calculators. And so if we're going to type this into a calculator, I just type in ln of 6 divided by ln of 3. And let's pull out our calculator. I'll crunch through some of these numbers because you're going to have to learn how to crunch these numbers. So let's actually do that. All right. Look up Wolfram Alpha. There we go. All right. So we'll just type in ln of 6. Oops. 6. Let me actually put it in parentheses so it doesn't get confused. Crunch through that number, and I get something horribly, horribly long. All right, this is what I was talking about. So here I'm using natural log. Here, Wolfram Alpha assumes that's the same as normal log, which is not true, because here, let me test something real quick with this crazy thing. So the answer here is 1.6. Please know what your calculator believes is what. Let's add a short. You should add a shortcut of to your doc. Oh, I probably should. Let me just see something real quick. So ln of, let me type in log of e. Tell me what that is. Yes, so on Wolfram Alpha, log of nothing is natural log. Natural log is also natural log. So remember how I said be careful about that? Here's a case where you should be careful. Can I type in log base 3 of 6 directly though? Yeah, so at least in this case, this is what your calculator is actually calculating. But you can actually type it in directly into Wolfram Alpha. So for our necessary, it's not super necessary that you do each one of these. I'll show you how to do it in a second. Let's just finish this real quick, and then I want to show you something. Okay, so here, if I type this in, I can actually type in log of, here if you have log on your thing, you can write log of 20 over log of 7. Oops, log 7. What that look like it to you for a second. Crunch that through, you get 1.54, and here I can have ln of 17 over ln of 6, and this is 1.558. Okay, and so this is just how you type it in if you were in a standard math class. So when you're in engineering classes and you only have a calculator next to you for your exam, you're going to type it in as log of whatever number over log of your base, okay? And whatever log function you have. Can you type in log base? Yeah, you can, and it works, right? So